This is Algebra 1, Lesson 29b, Zero Exponents, examples 29.6 through 29.9. If you didn't watch the first video from Lesson 29, I encourage you to go back because it's going to explain one way to know why a number to the 0 is equal to 1. Like 4 to the 0 is equal to 1. 5 to the 0 is equal to 1, etc. The lesson in the book doesn't show it the way I explained it in that video, but I have found that lots of students, that seems to make the most sense to them. So please go back and watch it. The lesson in the book tells us in this lesson a different way to kind of justify this. So I'm going to go through that way here. We already know from the previous video that 4 to the 0 is equal to 1, okay? And this is their way of knowing. They said, okay, imagine, look at this. If you have 4 to the 2 over 2, if you have the same number on top of the same number, right? Anytime you have like a number over itself, that's equal to 1, isn't it? 10 over 10, it's equal to 1. Because it just means 5 divided by 5, and that's 1. 10 divided by 10, and that's 1, right? We know that. So 4 squared divided by 4 squared has to be equal to 1, okay? So how does that help us? Well, we learned in the previous video, the one right before this one, that we can change this denominator and bring it out, okay, and write it in reciprocal form. So that would mean we have the top number, okay, it's in the numerator, and we can take this one and put it in the numerator if we would like by changing the sign of its exponent. So that's totally okay. So now we know that this 4 squared over 4 squared, yes, it's equal to 1, but it's also equal to this because of the way we rewrote it. So now let's simplify that. That's going to be 4 to the 2 plus negative 2, which is going to be equal to 4 to the 0. So hold on a minute. We know that this has to be equal to 1, and it also has to be equal to 4 to the 0. That must mean that 4 to the 0 is equal to 1. So there's another reason why. Okay, and you could do it with other numbers. 4 cubed over 4 cubed, same thing. We know that's equal to 1. We could also say, let's move the denominator up to the, the denominator up to the numerator, change its sign. Let's simplify that. That's 4 to the 3 plus negative 3. That's equal to 4 to the 0. So it must be true that 4 to the 0 is equal to 1 because these are all equal. And I don't think we need to show it again. They give you this definition. If x is any real number, important to remember, that is not 0, then x to the 0 is equal to 1. Okay, 0 to the 0 does not have any real value. But any other real number raised to the 0 is going to give you 1. Now, you're going to use what you've learned in the past to do these examples. You've learned that when you multiply things that have the same base, you add their exponents. So we have x squared times x to the negative 2. That's going to be equal to x to the 2 plus negative 2. When we put these together, that's going to be equal to y to the 5 plus negative 2. And we can combine those. 2 plus negative 2 is 0. Y to the 5 plus negative 2 is 3. Here's something a little new. X to the 0 then. Well, we know x to the 0 is equal to 1. So that's just 1 times y cubed. And when you multiply something by 1, you just get that answer. So the answer for A is y cubed. All right, here's 29.6b. Same kind of thing. We're going to put these together. Now careful, this exponent of the m is a 1. So that's m to the 5th, m to the 1st. So that's going to be m to the 6th. All right, now we're going to go over here and get our b squared and our b to the negative 2. That's going to be b to the 2 plus negative 2, which is 0. We know that b to the 0 is 1, and 1 times m to the 6th is just m to the 6th. 29.7 says use the distributive property to expand this. We should simplify it first because I see some things in there that would be much easier stated. For example, what is y to the 0? It's 1, right? So wouldn't it be much easier to just write that outside factor as this? Because this is just x to the 5th times 1, which is just going to be x to the 5th, and then times z. So it's much simpler to write it that way. So let's simplify it first. Here we have this z to the 0, which is just 1. So let's just write this p to the -3. Bring down the minus. Then we've got 4x to the -5, z to the -1. Okay? Now we're ready to use the distributive property. It made it a little easier on us. So let's take this outside factor and multiply it by this term and then by this term. Okay? So we're going to do the x to the 5th times this. So it's just going to be x to the 5th and then z and then p to the -3. All multiplied together. Now we're going to multiply that by this term. We know there's a minus between it. You could put adding a negative if you would like, or just go ahead and simplify it this way. So when we multiply these, there's no number over here, just a 1. So this will just be 4. Then we've got this z to the 5th. I'm sorry, I said z. X to the 5th, x to the -5th. X to the 5th, x to the -5th. You're going to do x to the 5 plus -5. So that's x to the 0. But x to the 0 is just a 1. And when you're multiplying by 1, you don't need that anymore, right? Now let's look at the z's. This z right here has an exponent of a 1. And this z right here has an exponent of -1. That's going to give us z to the 0, which is just a 1 multiplied by it. So this would be our final answer. Okay? All right. I don't see anything here that we can simplify beforehand. I don't see anything to the 0 that would be easier to write as 1. So let's go ahead and multiply this factor by this first term and then by the second term. So factor times the first term. Do you notice here? xy, -2, -2, +2, +2. How's that going to work? Well, let's look at this. This times this is going to be x to the 0, which is just a 1. This times this is going to be y to the -2 plus 2, which is 0. So that's just going to be 1. So 1 times 1, which is just 1. Now we need to keep that 1 because this times this is equal to 1. That's our first term. We don't have anything else here. Okay, if we had like a times 5, then the answer would just be 5, but there's not. There's not another number. So we need to keep that 1. All right. Then we're going to multiply this times this. So we put our plus sign down that we're copying down here. And then we have a number here that's 4 times this, which was just a 1 numerical coefficient that we don't have to write. So there's a 4. When I do this x to the -2 times x to the 4th, that's x to the -2 plus 4, which is going to be x squared. Now I'm going to do this x to the -2, y to the -2, y to the +2. That's going to be y to the 0, which is just 1. Now, do we need that 1? Well, it's that 1 times all of this. So it's just going to be all of this, right? So we don't need to have that 1 there. So our answer is this. And our last example has a couple parts. Simplify these. Any number to the 0, except 0, any number except 0, to the 0 is just going to be 1. Now, here the 2 is the base. Notice this is not in parentheses. So this is not -2 to the 0, okay? This is the opposite of 2 to the 0. So 2 to the 0 is 1. Let's take the opposite. The answer is -1. Here you've got a +1. Here you've got a -1. Let's look at this one. it is in parentheses. So the whole thing is being raised to the 0. So the whole thing is equal to 1.